In this lecture, we discuss an HDF5 technology called Compound Datatypes, which allow you to effectively represent tabular data. In the examples so far, the datasets that we've created have all been of a very simple type. For example, integers, floating point numbers, booleans, complex, and so on. And remember that just like a Numpy array, every element of a dataset has to have the same type. For example, this dataset consists of 32-bit integers. However, many real-world problems can't be described by simple integers, floating point numbers, or strings. For example, what if we had a series of information describing a collection of people? We might have a field for the name, their age, and another for their weight. How can we record this information simultaneously? Well, we could create 3 different HDF5 datasets, one for the name, being of a string type, one for the age, or an integer type, and one for the weight, a float type. We could then place those 3 datasets together in an HDF5 group. And for many applications, this would work very well. For example, if a program were trying to analyze the average age of our collection, it would be very straightforward to read from the age dataset and compute the average. However, in many real-world applications, we want access to the full record, which means the name, the age, and the weight all together in one package. If we use more than one dataset, we then have to aggregate all this information manually. Thankfully, HDF5 provides a native mechanism for handling this situation, using something called a compound data type. Compound types allow you to combine information of different types, for example, strings, integers, and floats, and bundle them together into one record. And for example, a 1D dataset of such types will give you a table with the full record in each element. So in HDF5, compound types are the native way to bundle together information of different types and store them as single elements in one dataset. The fields of a compound type can have any supported HDF5 data type. That includes things like integers, strings, and floats, but also includes other compound types. And once you've made a compound type, you can use it anywhere the native HDF5 types can be used. That means for making new datasets. It also means for attributes. In Python, Numpy supports a very similar mechanism called structured arrays. For example, we might use 20-character fixed width string to represent our name field. We might use an integer, Numpy dtype I, to represent the age, and a float to represent the weight, Numpy dtype F. We can then construct a custom Numpy dtype, which is a combination of these 3 atomic types. We give each type a name, here, name, age, and weight. These are called the fields. We create a new Numpy array using the custom type, and then we can populate it. Note that each element of this 1D array is being initialized to 3 values, which fill in the 3 fields in the structured type. If we examine the dtype property of our array, we can see that it has fields for name, age, and weight. The dtype object also has a property called .names, which prints the names of all the fields. Since we know the field names, we can request that Numpy return to us just the data corresponding to particular fields. For example, we can slice into our array using a list with the entries name and weight, and Numpy will produce a new array containing just the name and weight fields from the original array. The H5Py package uses Numpy structured dtypes to represent HDF5 compound types. For example, let's suppose we wanted to create a dataset to store our name, age, and weight information. First, we create our custom Numpy type with fields for name, age, and weight. Then we create an HDF5 file. And then, when we create a dataset, we supply a name, table, a shape, in this case, 10 elements, a 1D array, and we specify the dataset should be of this custom type. Then, we can initialize the entries from the Numpy array we already created. If we investigate the contents of this dataset, we can see that its dtype is the structured type we created in Numpy, as fields for name, age, and weight. And then, if we were to read the data from the dataset, we see that we get back a 1D Numpy array with structured fields. Just like Numpy, you can access the data in the dataset corresponding to certain fields. For example, if we were to retrieve only those entries corresponding to the field name, we would get back a 1D array containing Numpy strings. Or if we asked for both the name and the weight fields, we would get back a 1D Numpy array whose fields were name and weight. Importantly, H5Py allows you to mix field names and slices. So for example, if we wanted to load just a portion of the data in our dataset and to restrict the data to just the name field, we could specify the name and also the range 5 to 9, in which case we get back a 4-element 1D array containing only the strings. We can also specify multiple fields along with our slicing. H5Py figures out that we want just the name and weight fields and returns a 1D array, in this case 3 elements long, with a custom dtype containing just the name and weight fields. Let's use HDFU to examine the contents of our compound dataset. We'll open the file, table.hdf5, and we can see in the left-hand tree view, our table dataset shows up. You might notice the icon this time is different. If we right-click and do Show Properties, we can see that HDFU has identified this dataset as being of compound type. So, if we open the table, we can see that HDFU will use the field names as the columns in the grid display. So HDFU can be used as a very convenient application to preview data formatted as a table. Some things to remember when using compound types. They are the native way in HDF5 to represent tabular data. If you find yourself making multiple data sets which have to somehow be synchronized, you should consider using compound types instead. The fields of a compound data type can have any type supported by HDF5, and compound types can be used anywhere that a native HDF5 type is used. And in the Python H5Py package, you can use the exact same syntax and dtype system that you use in Numpy for handling structured arrays.